The purpose of this video is to review the process of solving systems of equations algebraically. The first set of equations that we're going to try to solve simultaneously are the ones on the right here, 4x plus 3y equals negative 1, and 5x plus 4y equals negative 1. The important thing to know when you're trying to solve a system of equations algebraically is the connection to geometrically. Each of these is the equation of a line, and the solution is where the two lines will intersect, which leads us to three possible scenarios. Scenario 1 being that the two lines intersect in exactly one place, so you get one solution. The second scenario is that the two lines that you have represented algebraically actually represent the same line, and therefore they intersect everywhere, so you will have an infinite number of solutions. And the third possibility is that the two lines are parallel, and you have absolutely no solutions because parallel lines never intersect. With this said, we're going to solve this by the method of elimination. Now, the other method you should have learned in the past is substitution, but I'm focusing right now on elimination because when I look at this, the x's are lined up really nicely and the y's are lined up really nicely. And it would be really nice if I can just add the two together and get one of the variables to drop out or be eliminated. And the only way that will happen is if, when we're doing this, they have the same coefficient but opposite signs. So I've decided I'm going to try to eliminate the y's. So I think to myself, what do 3y and 4y go into? Well, obviously it's 12y. So I want to take the entire top equation and multiply it by a 4, and the entire bottom equation and multiply it by a 3. However, if I distribute each of those, I would have two 12y's, one on the top and one on the bottom, and they wouldn't cancel. So I'm going to multiply the bottom by negative 3. The result is the following. 16x plus 12y equals negative 4. Negative 15x plus negative 12y equals 3. Now you can see pretty clearly that when I go over here, if I were to add these two equations together, the y's would drop out. So that is exactly what I'm going to do. I'm going to do 16x minus 15x and get 1x is equal to, and in this case it's negative 1. Now thinking about this, this is telling us that the lines intersect in a point that has an x-coordinate of negative 1. But it's really important that we go back and figure out what that y-coordinate is. So the next step is to go to either one of the original equations, and I'm just taking the top one, and plugging in x is equal to negative 1. So if I do that, I get 4 times negative 1 plus 3y equals negative 1, which gives us negative 4 plus 3y equals negative 1. If I add 4 to each side, I'm going to get 3y equals 3, and I'm going to end up with, ta-da, y equals 1, which means that the coordinate of the point where the two lines intersect is negative 1, 1. And that, my friends, is our solution. Moving on, what we want to do now is focus on solving systems of equations with 3 variables. In other words, we're going to have 3 equations with 3 unknowns. Geometrically, when we have 3 unknowns, what we're graphing instead of a line is a plane. So if you look over to the left here, you could see what can happen if we graph 3 planes. The first scenario is that the planes intersect in a line. So I'm just going to kind of highlight this here, this line. there's your three planes, they intersect in a line, and everywhere along that line is a solution, so it's going to have an infinite number of solutions. The second option, that can happen is that we can have the three planes intersect in exactly one point. And the last scenario that can happen is that the three planes do not intersect at all. In other words, they're parallel planes, and we have no solutions. Okay, let's get to work now on solving this system. And again, it's set up for elimination because I have the x's lined up, the y's lined up, and the z's lined up. Now, looking at this, if I look at this first equation and this last equation, it looks pretty nice to me because I can very easily add those together and eliminate the y. So I'm going to have x minus 2y plus 3z equals 7, negative 3x plus 2y minus 2z equals negative 10. When I add those together, I get x minus 3x is negative 2x. My y's cancel. 3z minus 2z is plus z equals 7 minus 10 is negative 3. Okay, with this said now, I'm thinking to myself, I'd really like to have another equation with just two unknowns that I can combine with the one I just found. So what I'm thinking about doing is maybe I'm going to go right here and move this line down here and say, could I eliminate the y from those two? And you can see pretty nicely that if I multiply the top equation, and let's do this, let's multiply the top equation by 2 and the bottom equation by negative 1, then when I add the two together, the y should drop out. If I do that, 2 times 2x is 4x plus 2 times y plus 2 times z equals 8. Now going over here, negative 1 times negative 3x is going to give us 3x. 2y times negative 1 is negative 2y. Negative 1 times negative 2z is plus 2z. And negative 1 times negative 10 is 10. Now again, if I add these two equations, I'm going to get 7x. The two y's cancel, plus 4z equals 18. Now here, my friends, is where I'm going to leave it to you. Because if I have now broken this down to eliminating the y, and now I have two equations, one right here and one right here, set up to solve by elimination. Once you've solved by elimination, you should be able to then solve for either z or x, and then plug in and back solve for the others. So I'm going to leave you here, and when you come in class tomorrow, your goal is to be able to tell me, what does x equal, what does y equal, and what does z equal, pending that there's, I don't even know why I wrote that just now. What does z, I meant to write a question mark there. And here we go. Let's go question mark, question mark, question mark. What do those equal so that when I have those three equations, I have their point of intersection? Have fun.